Welcome back to the deep dive. So, if the 2022 launch of ChatGPT was our big collective AI moment, then what's happened since has been this frantic race.
A race to figure out where all that intelligence should actually live.
Exactly. We've got a mountain of sources here, articles, industry forecasts, technical papers, and they all point to one critical theme. AI is leaving the cloud. It's heading for the real world.
It really is. And it's not just a trend. This is a massive market transformation. We're diving into edge AI, which, it's the fastest growing segment of the entire AI wave.
How fast are we talking?
Our sources are projecting a staggering 37% compound annual growth rate for edge AI through 2030.
Wow.
Yeah. And that's way ahead of the overall AI market, which is at 28%. It's a huge signal that the economics and just the physics of data are changing everything.
Okay, let's unpack this for you. For the last decade, we were all told to be cloud first.
That was the mantra.
It was all about scale, flexibility, centralized power. So what is the fundamental friction point that's making the edge so urgent now?
The single word is latency.
Latency.
Yeah. Cloud-only architectures, they rely on that whole round trip from the device over the network to a data center.
And then all the way back again.
And all the way back again. That distance, that round trip, it introduces a critical delay that, well, it just can't be tolerated for real-time interaction. Businesses love the power of cloud AI, but they're finding out they just can't afford the delay.
And give us some concrete consequences here. We're not just talking about an extra second for a web page to load, are we?
Oh, not at all. Far from it. Think about safety-critical situations. They're the most obvious failure points.
Like a self-driving car.
Exactly. And if you have a robo-taxi waiting even half a second for a round trip to the cloud to confirm, hey, that's a pedestrian stepping off the curb.
That's the difference between a near miss and a tragedy.
It is. Or in manufacturing, delaying the halt of a high-speed conveyor belt because a defect was spotted just a moment too late. That can cost a company hundreds of thousands of dollars.
And it even filters all the way down to our daily lives, right?
Absolutely. Even in your smart home. That frustrating, rocky, delayed feeling when you give a voice command and the lights sort of, think about it for a second and then turn on.
I know that feeling.
That's often latency. It just breaks the illusion of intelligence and speed.
So the mission of this deep dive is to explore why businesses that need that speed, that resilience, and privacy are now looking to the edge. And we're defining edge AI simply as AI in the real world.
Putting the models right on the device.
Right, on the sensor, the camera, the industrial controller itself.
It means putting the intelligence right where the data is being born. This allows for immediate processing, immediate response, without relying on that constant critical network handshake with the cloud.
I have to challenge the premise a little bit here for our listeners. Is the cloud going away? Is this suddenly an either-or thing?
No, not at all. That's a great point. The future is a hybrid balance. The cloud still provides crucial services. Massive scale for model retraining, data oversight, global deployments.
The heavy lifting.
The heavy lifting, exactly. But the edge is now taking over as the forefront of intelligence. It handles the time-critical, low-power decisions. It's where intelligence has to live in the moment to actually be effective.
Okay, here's where it gets really interesting. Let's look at the foundational drivers for this gravitational pull to the edge. Our sources point to three big aha moments that make the move pretty much unavoidable. The first one is just the sheer explosion of available data.
The volume is staggering. Today, something like 75% of data is actually created at the edge.
Not in data centers.
Right, not in data centers. Your devices, your sensors, they're generating so much raw information, video streams, temperature logs, movement data, that trying to send all of it to the cloud for processing is, well, it's economically and physically impossible.
So edge AI becomes the only way to actually use that data.
Yeah, it's the only viable path. And for scale, just think about this. We're looking at a projection of 40.6 billion IoT devices globally by 2034. That is a lot of data points.
Wow. Okay, and that brings us perfectly to driver number two, the huge surge in compute performance.
Exactly. We wouldn't be able to talk about processing all that local data if we didn't have the hardware to handle it.
So what's the specific innovation there?
The key innovation is the neural processing unit, or NPU, and the real insight isn't just that they exist, but that their architecture is so specific. It's optimized for the kind of math machine learning relies on.
This is more efficient.
Massively more efficient. We're talking 10 to 100 times the inference efficiency per watt compared to a general-purpose CPU. That's the tipping point.
Yeah.
That's what makes local ML feasible, even on tiny, tiny devices like microcontrollers or MCUs.
And the market reflects this. We're expecting almost 5.7 billion edge devices to be sold by 2031.
That's the projection.
So data volume forces us to process locally, and thankfully the hardware is caught up. But that third driver, the massive energy and resource use of the cloud, that takes this from just an economic problem to an ethical one, a sustainability imperative.
It absolutely does. The resource strain of these massive cloud data centers is dramatic. A data center, especially for large ML models, can consume up to 40% of a community's entire electricity budget.
40%.
And it's not just energy. A single large-scale data center can consume up to 5 million gallons of water a day, just for cooling.
Wow, 5 million gallons.
Yeah.
That is a truly shocking footprint, not to mention the noise you pointed out in the sources.
Precisely. They operate at noise levels of 92 to 96 decibels. That's genuinely disruptive. So moving workloads to the edge where the data is created, it's the necessary path forward. It lowers energy use, it lowers cost, and it increases impact.
I follow the logic on energy, but let me ask a challenging question. Doesn't sending all that raw data to the cloud for training still use a ton of energy? Aren't we just shifting the problem?
That's an excellent point. And yes, the cloud absolutely keeps the advantage for that initial heavy training. But edge AI reduces the constant transactional energy cost of inference.
Okay.
Once you deploy a small, efficient model to a device, it runs constantly on minimal power. You only send small, filtered results back to the cloud for oversight, not continuous raw data. So you shift the energy cost from constant processing to occasional communication. It's a huge net reduction.
That makes sense. So if a business or developer is looking at a new AI use case, how do they decide if the edge is the right fit? We have a great acronym from the source material for this, the BLERP check.
The BLERP check is a fantastic, memorable tool for this. It stands for 5 critical areas that almost every successful edge AI project hits.
All right, walk us through them.
So B is for bandwidth. If your device generates terabytes of data, but you only have a weak cellular connection, you have to process locally to minimize bandwidth costs.
Makes sense. And L, we've already hit this one, but it's central.
L is for latency. The real-time processing needed for applications where time is absolutely critical, decisions in under 10 milliseconds. E is for economics. This covers optimized resource use and reduce energy consumption. By processing locally, you don't pay those continuous cloud compute fees. You only connect when you absolutely have to.
Okay, R and P are next.
R is reliability. This is crucial for operating in places where connectivity is just bad or intermittent or doesn't exist at all. Think a remote mine, a container ship, or even just a cellular dead zone outside the city.
And finally, P.
P is for privacy. And this is arguably the biggest game changer for consumers. The data never leaves the device.
That's huge.
It's processed securely, privately, right on the spot. This is essential for sensitive health, financial, or even home surveillance data.
The smart wearables example really illustrates those last 3 perfectly. Economics, reliability, and privacy. We all know the pain of battery life, right?
Right. So for economics, local processing saves critical hours of battery life because the device isn't constantly powering up a radio to send raw sensor data to the cloud. Less drain, fewer charges.
On the reliability.
For reliability, if you're out running and you lose your phone signal in a tunnel, your biometrics and GPS still matter. They have to keep working, and they do because the model is on the device.
And privacy for health data is just paramount.
Absolutely. Today, a lot of our wearable data gets uploaded to the cloud. With Edge AI, you have the choice. You can keep sensitive biometrics, like your specific heart rhythm patterns, processed and stored only locally. You control that privacy.
Okay, now that we understand the drivers and the applications, let's get into the mechanics. While inference happens at the edge, the whole workflow is still a smart collaboration, isn't it?
It is. It's a 4-step cycle. It begins at the edge itself. Sensors collect raw data, and it's immediately pre-processed.
Meaning what, exactly?
Things like denoising an audio stream, resizing a video frame, or filtering events to capture only the relevant action. And crucially, privacy is enforced right here by stripping sensitive info and encrypting the result.
So the centralized cloud power still handles the heavy lifting of training.
Yes, exactly. Model development and the heavy training happens in the cloud. Models are trained on massive, curated datasets that reflect real edge conditions. Think variable lighting, motion, noise.
And engineers are using things like ML ups here.
Yes, MLOps or machine learning operations is key.
For the listener who hasn't heard of MLOps, what does that change?
It's basically applying robust software principles to machine learning. It means you automate the deployment, the monitoring, and the updating of models. For the edge, MLOps makes sure those tiny, optimized models get pushed out reliably to millions of remote devices instead of it being this manual, painful process.
Got it. The model is trained and ready. What's next?
That's the optimization and deployment phase. To make a model fit on a tiny, low-power chip, it has to be shrunk down. This is done through techniques like quantization or pruning.
If you clarify that, it sounds pretty technical.
Sure. Think of quantization like shrinking a high-res photo down to a thumbnail. We accept a little less precision in the numbers, which saves a massive amount of storage and power, but it doesn't really degrade the quality of the quick local decision.
And pruning.
Pruning is even simpler. It's just cutting out the parts of the neural network that aren't contributing much to the final answer.
Brilliant. Okay, finally, the model is in the field.
And that's field inference. Decisions are made locally, respecting those strict resource limits. The models operate with confidence thresholds, and, if needed, they can fall back to simpler models or even request human oversight for low-confidence decisions.
This whole system brings us to that critical year, 2026. The source material says 2026 is the major inflection point. Why that specific timeline?
IoT analytics suggests that 2026 is to be the inflection point when IoT OEMs scale from early 2025 pilots to broad portfolio refreshes, marketed as edge AI-enabled IoT devices.
So that's the moment it goes mainstream.
That's the moment it shifts from a niche engineering achievement to a mainstream product feature. It accelerates the move from basic telemetry, just sending data, to endpoints that support sophisticated local inference. We, as consumers, will start to see it everywhere.
And we're certainly seeing the market momentum to back that up.
Absolutely. The whole ecosystem is maturing rapidly. You see the big acquisitions like Qualcomm buying Edge Impulse, NXP buying Kinara. That tells you the hardware makers know they need the software.
And the collaborations, too.
And maybe more importantly, there's massive collaborative growth in organizations like RSTV International, the AI RAN Alliance, and the Edge AI Foundation, a global nonprofit with over 100 tech companies and universities all working to standardize this stuff.
Let's dive into the key technologies enabling this 2026 pivot. What are the advancements that make this local processing on tiny devices even possible?
The tech stack is seeing some incredible breakthroughs. First, we're seeing SLMs and generative edge AI. For years, generative AI was strictly a data center thing. Now we have small language models, SLMs, running on extremely constrained devices.
Wait, generative AI, which we associate with billions of parameters on a tiny microcontroller, what does that even unlock?
It unlocks truly advanced contextualized local action. So instead of just detecting motion, the device might understand the intention behind it. Is this a person or a dog or a delivery driver? And then generate a relevant localized response without ever calling the cloud.
That is a huge leap in capability. What's the second big technology?
Agentic Edge AI. Since modern chatbots launched in late 2022, models have gotten much better at complex reasoning. We're now moving that autonomous agency to the edge.
Agency meaning?
Meaning the ability for the device to act intelligently on its own based on complex local context. This is really important for warehouse robotics and dynamic factory floors that need immediate decentralized decisions.
And third, something that sounds like it's straight out of science fiction. Neuromorphics.
Neuromorphics. These are systems designed around event-driven architectures. Think of them less like a digital calculator that's always running and more like a biological brain.
Okay.
They only wake up and consume power when they detect a relevant stimulus. This radical efficiency makes them a phenomenal fit for things that need continuous, passive monitoring like wearables, hearing aids, or implantables.
So if we're deploying billions of these intelligent, autonomous, tiny devices, how on earth do we manage them all?
That's the fourth point, sensor-to-server orchestration. You can't manage thousands of unique endpoints manually, so companies are using cloud-native techniques like Kubernetes K8s and K3s to manage them all seamlessly. It's like having a universal flight controller for all your devices.
And finally, the problem of all the different hardware. How do developers make their model work on dozens of different chips?
That's the fifth essential ingredient, compiler tech and model portability. Because Edge AI is so focused on efficiency, every millisecond, every microwatt matters. Developers need tools to easily port and compile models for different hardware without sacrificing that hard-won performance. This just accelerates time to market dramatically.
So let's wrap this by looking at the massive real-world shift. ABI Research projects almost 5.7 billion chipsets for edge AI by 2031. Let's run through some key industries and link these applications back to the BLERP drivers.
Let's do it. Starting with manufacturing. Edge AI is essential for real-time quality control. An edge camera spots a defect instantly and stops the line before a bad item goes through. That's pure low latency and better economics.
And predictive maintenance.
And predictive maintenance, where the machine monitors itself and signals when it needs service. That boosts reliability.
In mobility, the stakes are, well, they're existential.
For autonomous vehicles, low latency is non-negotiable for things like emergency braking. It's a life safety issue. And vehicles need disconnected operation, which is reliability, because they have to work perfectly in a remote canyon with no signal.
And privacy in the car.
Exactly. Local processing also allows for personalized in-cabin experiences where your sensitive data stays on device for privacy.
Okay, moving to retail.
In retail, loss prevention uses embedded edge AI and security cameras to process footage locally. This slashes the bandwidth needed because only alerts get sent, not hours of video.
And for personalization?
For personalized shopping, on-device processing can react to what a customer is doing immediately, displaying a targeted promotion that's low latency. And it can instantly discard sensitive tracking data for privacy.
The impact extends to agriculture, too.
Absolutely. Precision farming relies on drones and sensors to analyze crop health across huge farms. This demands high reliability and low bandwidth, since high-speed internet just isn't everywhere.
And livestock.
Livestock monitoring is similar. Wearable sensors process biometrics locally, which saves battery life. That's economics. And they operate flawlessly in remote pastures, which is reliability.
Finally, the public sector, which deals with high security, high stakes environments.
For classified operations, edge AI is critical for high security because the data never leaves the device. That's privacy. In disaster response, where infrastructure is gone, systems must have high reliability.
To provide real-time situational awareness.
Exactly. Fusing sensor data locally for immediate mission-critical insights. That's a low latency requirement.
What a fantastic deep dive through this material. The takeaway seems crystal clear. Edge AI is driven by the fundamental limits of the cloud latency resource strain, and it's enabled by a revolution in small, powerful hardware. That BLERP check is really the compass for deciding when to move intelligence to the device.
That's right. Edge AI is fundamentally changing how we interact with devices in the physical world. It's creating intelligence that is truly local, instantaneous, reliable, and respectful of your privacy. It just makes the world smarter and faster.
So what does this all mean for the future beyond just the tech?
Well, the foundational work here requires massive coordinated effort. We mentioned the collaborative nonprofits like the Edge AI Foundation. You have to consider the scale of this collaboration. We are talking about putting truly autonomous agentic AI directly into billions of everyday devices.
Okay.
So how will these collaborative structures manage the incredibly complex security challenges that come with that? Distributing immense decision-making capability across an impossibly wide attack surface. Well, securing 5.7 billion endpoints is not the same as securing 24 data centers. That, right there, ensuring resilience and trustworthiness at that kind of scale, that is the next great task for this industry to tackle.